Hi, my name's Sterling Brumbaugh. This study, we looked at the impacts on parasites on largemouth bass in a small coastal plain impoundment. Largemouth bass are a popular game species and important for recreational fishermen through the state or private properties. For this study, we want to look at how this parasite, chondrocecum, impacts the age and growth rate of largemouth bass. Our study area was ABAC School Forest, which is roughly a 15-acre impoundment. How we collected the fish, we used a combination of hook and line sampling and electrofishing. Electrofishing is the act of putting electricity in the water and pulses, stunning the fish, allowing them to raise, and allow managers to collect them. So we did that in two ways. Once the fish were captured, we weighed and measured each fish. We use those measurements to get a ratio called relative weight. What relative weight is the overall health. It's a ratio that managers can use to look at the overall health of fish. So we got that. Each fish was dissected or necropsied, and we gathered parasite loads from each fish. So each fish, each parasite was removed and counted. Each fish was also had their otolith removed, which is their inner ear bone. I got a picture of it down there, and also have one with me.
We didn't take any information.
What otoliths are small inner ear bones of fish. Managers are able to cut them using a jeweler saw. On that jeweler saw, you're able to flip them out and count them like rings on trees. So you're able to accurately age a fish based on this inner ear bone. So once we got all the data, the parasite loads, the relative weights, and the ages, we were really able to understand the pond a lot better. So our oldest fish was 6 years old, which is not out of the norm for a pond, but the fish was less than 2 pounds. So it's normally a 6-year-old fish should weigh about 6 pounds, about a pound of body weight per year of growth. And what we're kind of expecting with the parasite loads and the body conditions was, as the parasite loads increase, the body conditions would decrease. And we kind of got that. So we did have a negative trend line on our graph, and that's kind of as to be expected. So as the parasites increased in the fish, the relative weights decreased, which is, like I said, what we expected. So, and future of this pond, ABAC and the wildlife, or part of my senior project, will be renovating this lake. We'll do that by applying a chemical to the lake, and that chemical will remove all aquatic organisms that take in oxygen through the water. It's called rotenone. Rotenone is a popular chemical for that. So something I probably should have touched on before is the life cycle of this parasite, how it gets into the ponds. It has 3 hosts. They'll have birds or mammals, crustaceans, and fish. So birds will defecate in the water. Crustaceans will then eat the feces, which contain the eggs. Those eggs will turn into juvenile parasites, and then the crustaceans will get eaten by the fish, and then in turn the fish get eaten by the aquatic birds and mammals. That will complete the life cycle. So by removing the fish and the aquatic invertebrates, we're hoping that should renovate this problem or get rid of this problem of the parasites at such a heavy load. It's important to remember that these parasites naturally occur in nature and are part of the ecosystem. So we just want to reduce the numbers so we have good, healthy fish. Maybe not quite remove them, even though that wouldn't be a bad thing at all. So thank you.